Hi students, let's look at this question which was taken from the year 2015 Hwa Chong Institution, paper 1, question 11b. Alright, so we are looking at the question regarding, what is this called? Graphing techniques. Okay, and you are given that a curve G has this equation and has this stationary point and a vertical asymptote x equals to -2. So that's okay. So let's see how can we go about doing this. I think this is pretty okay. Shouldn't be a very difficult question. You should be able to do the first part, which is to find A and B. So stationary point, this tells you that dy dx is 0 lah, when x equals to -4. So that's okay. That's the first part. But you could just substitute -4 and -1/4 in. But what I'm more interested is the vertical asymptote, because from here we know that actually the vertical asymptote x squared minus b cannot be 0, right? So the VA will just be plus minus root b. Sorry, it should be x vertical asymptote should be x equals to plus minus root b lah. This is what you're looking at. Okay, so try and see how we can go about doing. So this part here, you are told that one of the equation is actually -2 lah. So hence, okay, root b is obviously positive lah, because if not, you wouldn't have a vertical, you wouldn't have real solution lah, right? So that's just so you know. So hence, you know that actually -2 is actually minus root b. Okay, that's what you can deduce. Okay, yeah. So anyway, b is just 2 square, which is actually just 4. This is okay. This is redundant. You don't really need to write this out. It's fine. Okay. Then you will have once you've done that, really, what you're just gonna do is just gonna substitute sub x equals to -4 and y equals to -1/4 into g lah. So this would be -1/4 equals to 2 minus 4 plus a over -4 square minus 4. Okay, so this part here, what we'll get is actually just 16 minus 4 will be 12. So it's -3 equals to -8 plus a. So a will just be 5. Yeah. Okay, so that's what you will get. 2 marks, pretty straightforward marks, I think. Let's look at the second one. Find the range of value of x for which g is increasing and is concave downwards. Okay, concave downwards. So we try to understand what is increasing. Increasing would just means that dy dx bigger than 0 lah. Okay, concave downwards would just means that it's like that. This is concave downwards. Okay, this is concave upwards. So concave downwards would just means that d square y dx square, the rate of change of the gradient is max less than 0. Okay, it's decreasing. Okay, so that's one way. Then yeah, so we try and see how we can try and see how we could do this part here. Okay, it's okay lah. So what I'm going to do is I'm just going to key in calculator for this equation here. So g, you have got the expression, you have everything already, right? So 2x plus 5 over x square minus 4. This is the expression here. So what I'm going to do is I know that there's no the horizontal asymptote is y equals to 0. Vertical asymptote is just x equals to 2 or -2 lah. So that's okay. So what I'm going to do is I'm just going to use your GC, but in my case I'm just going to use my favorite Desmos graph to the go. So this will be 2x plus 5 on top, 2x plus 5, and below will just be x square minus 4. That's over. Okay, so basically x equals to 2, x equals to -2. Okay, same thing. The reason why I'm doing this is because I like Desmos, but you just key your GC, you should be able to get it. Okay, So this is what you get. So you realize there's a mean point there. Likely there's a mean, because this would actually decrease to 0. So you could actually find, oh, there you go, this is the mean point. Oh, because the question also gave you the mean point, so you will have a mean point, yes. Please, yeah, any question, just let me know, okay? So this is a graph here that we're looking at. I'm just gonna put into the graph we have here. So hold on, this is just like that. Okay, now once we get that already, it's pretty okay. So we know that y is 0 here. This is x equals to -2. X is equals to 2. You could actually very quickly find the max point by using GC lah. So that's not the point. But let's look at, oh yeah, actually you need the GC because you need the increasing, right? So you just can calculate. This is -1, -1. So we have -1, -1 here. I trust that you know how to find -1, -1. So this is -1, -1. And after that, the minimum point was actually -4, -1/4. So -1, -2, -3. So I try to be like, okay. So that's about it. Okay, great. So once this is done really, you need it to be increasing and concave downwards. Now concave downwards, right, doesn't have to be connected, so it could just be like that lah. Either any of these side shows up, that's your concave downwards. Okay, we look at the increasing function first. Okay, increasing. So I'm gonna highlight the part which is increasing. So increasing will just means that we all know increasing, right? Just means it's increasing as with respect to y, where as y increases, x also increases. So that's the idea of increasing. So increasing part will be here. So this is increasing, right? This is increasing. Here is decreasing, right? It decrease, that will be increasing. So here is also increasing, but here onwards will be decreasing. So I would only, this is decreasing as well. So I don't really care. This is decreasing. No. So there are only this portion here, -4 to -1, without -2, which are increasing. Right? So within this is the only range which is like increasing. Okay. Then after that, you think about it. You need a concave downwards. Okay. So I'm going to use another color to code it. Concave downward is any shape like that. So any like going up and then taper off the top and then coming down like just like this. This is a shape where it's like any shape. So let's look at that. So concave up. This is not concave. This is concaving downwards and downwards. Okay, because concave downward is like that. So this part here is this one. This part here is this one. So it's not really concaving. Unless you're talking about, yeah. Okay. So this part. Okay. Yeah. Anyway, we don't really. It's too small lah. Because anyway, there are only two increasing. We are more interested in the. So this is definitely concave downwards. This whole stretch here. And this part is not concave downwards. Okay. So it's okay. So as you could see here, the overlapping part is here because you want this purple and the orange color highlighted one. So basically what you need is basically this one. This region here. -2 to -1. Okay. So this is where. So from the graph, you could see that from GC, maximum point is -1, -1. You just sketch a graph, it's fine. So increasing from graph for increasing and concave downwards. Range is from -2 to -1. Okay, you shouldn't equal to -1 because -1 is not really increasing or decreasing. It's stationary value. So yeah, it's stationary value. So you shouldn't include the -1 there. Okay, so that's how you do it for part 2. I think part 2 is pretty okay. You're not even asked to sketch the G, man. Right, okay. Okay, come, let's look at that. I'm not sure, man. Like, okay, let's look at that. So by sketching a suitable line on the same diagram as G, find a number of distinct real root equation of this lah. Okay, this is the one that I hope this part here. I'm gonna pause for a while. Now, so if you're given this kind of graph, right, it looks weird, right? So what will you do? I'll tell you what I'll do. Okay, so if you're not sure how to even start, right, the easiest way is just do a long division. Okay, that's the reason why we call it denominator. Denominator means it dictates, denominates in the kind of currency that you're looking at in the equation. So x squared minus b is the denominator. So if you can't see what's going on here, you just do a long division, and then everyone will say x squared minus 4. I'm just going to do a long division. I don't even know what is going on. But if it doesn't work, then I may need to employ other methods. Okay, so I'm just going to do a quick long division. X squared minus 4. So this will be 5x. So this is 5x cubed minus 420x. This will be 2x squared. This will be my goodness. Sorry, x plus 7 plus 2. So it's 2x squared minus 8. So this will be 6x plus 15. Ta-da! So what I'll get is actually just 5x plus 12. Then let me see. Suitable line, right? You want a suitable line, right? So x squared minus 4, 6x plus 5, 3. If I bring up the 3 out, oh, there you go. There you go. So if you see that this is a multiple of g, this one. So this part here, if I were to bring the 3 out, 2x plus 5, there. Okay. Now bear in mind, this is my first time seeing this question. I don't even. Oh, yeah. So I never refer to the marking scheme only until the very end, like to see whether the workings are correct. So that's why it's useful to just see and think. This is 4 minus, so this is 5 over 3x minus 2 over 3. Okay, so this is your g. That would be your, this is pretty okay, I think. This is g. This is your g, this is your g, which is your y1 is g. This over here will be your y2, which is minus 5 over 3 minus 2 thirds. Okay, so what if you want to find the number of distinct real root, what you do is just sketch a curve lah. Just sketch a curve. Minus 5x. So yeah, get your trusted GC, or your, in this case my trusted graphing calculator would be my Desmos. Powerful, man. You all should know how powerful Desmos is. Okay, Desmos is it's just a good invention, man. I love it. Okay, so anyway, so once you get it really, oh, this cuts at here. Does it cut? So hard to see. Oh my goodness, how to see? Okay, in exam, as I would encourage you to just zoom into this side here, because you may not be the first thing you must always know is whether it touches one time. Always just don't doubt yourself. Like, don't just trust your GC, like whether it just cut once. Whenever you see this, it's may not be one. So I can see that some students may think they only cut once here, but it's not. If you were to zoom in, oh man, come on, seriously. If you zoom in, there are two intersections here, which can be really found by your GC. So from the GC, the number of distinct resolution, number of solutions would be 3. So just 3 lah. It cuts 3 times, intersect twice. So 3 times. That's about it. Yeah, so intersect twice. That's about it. Okay, so I think this question is pretty okay. I think, yeah, it's okay. So, but any question or comments, please let me know. Please keep practicing. See you in the next video.